So after that, we started talking about software reliability, and after that we looked at software reliability. Looked at some of the static ideas. So I did a comparison of hardware versus software reliability methods, how mature they are and what you can expect. We looked at some of the factors that impact defect density, and we then looked at dynamic or software reliability growth models. We looked at operational profile, and I incidentally mentioned that if you want very high degree of reliability, optimal testing may not be operational profile testing. Yeah, you should use probably a different mix. And we looked at the exponential SRGM. Now in your representation, you referred to a model as the Goel-Okimoto model. I think that is the same as the exponential. And the one that you referred to as the Musa-Okimoto model, that is what I referred to as the logarithmic model. Those are the two most common models. We looked at the significance of parameters, and we looked at how the models can be compared and what can be a good way of comparing models besides just looking at goodness of fit. We looked at the module size distribution and its connection with defect density. That is based on some of our work. And we looked at test coverage and system reliability. So there we saw a way where instead of using time, you can use coverage to see how much testing you have done, and hence how many more defects you may find. Now then, after the second test, we also saw some other things. We saw reliability of multi-component systems. So we saw that if you have a system with sequential execution, then what would be the reliability of a software which has a number of modules, such that one module is under execution at a time. So you might have in the final maybe a question based on that. I'm not sure, but it's possible. And then we also saw inversion programming, and we saw a numerical example based on that was constructed by Hatton, and that showed that if you have statistical correlation, you lose quite significantly in terms of reliability improvement. But even then, the improvement may be justifiable, because you may not be able to get that type of reliability improvement by testing alone. And then we looked at optimal reliability allocation, which is a classical problem, and we saw how it would be applied to software reliability, and we saw some simple mathematics. I mentioned about the Lagrange multiplier approach, which I guess if you are doing research, you probably should know about Lagrange multiplier approach. But I guess if you are an engineer, you have probably seen it. But based on that, we obtained some expressions, and using those expressions, we can see if you have a bunch of modules, how much testing time you should allocate to different modules in order to achieve high reliability. And we saw that under some assumptions, in the optimal situation, it turns out that one optimal situation would be when all the modules have the same defect density, and that would represent optimality. So that would mean testing all the modules. So bigger modules you test it for longer time, smaller modules you test for less time, but you should test for all of them. And okay. And also I mentioned about reliability of a software system where components are executing concurrently. And I had mentioned that in that case, you need to add the failure rates, because if any one of them fails, the system will fail. So that's what we did. And there are other interesting things that that I mentioned in the beginning. For example, information redundancy, we haven't done that. But that's also a fascinating topic, and there are others. But I think for a semester, I think we covered a fairly good amount of material. And I think about our presentations, I haven't tried the presentations in this class in the past, because in the past this has been a bigger class. So I guess I'm always happy to see more students. So bigger is not bad, bigger is of course good. But then you have to allow enough time for everyone. So I think this turned out to be, I think they were good presentations. So I think if there is time, then I should try that in future also. In 635, typically the number of students is small, and in any case, most of the speaking is done by students there. So there we tend to have a lot more presentations. So any questions about the final? So you guys are all ready for the finals? So this is right on Monday, right? Monday morning.
Monday at 9, 10.
So at 10 after 9?
And it's going to be here.
Yes.
Yeah, we'll be here. Yeah.
Yes, I know.
So
is,
we'll
it
be
about, is it going to be about the same size as the other two tests, or will it be bigger?
Oh, the test?
Yeah.
Well, we do have 2 hours available. So in the past, a few years ago, I would sometimes give 1 hour finals, but then people would complain. They said, well, we had 2 hours available, why did you give us only 1 hour? So they said, okay, I'll make it a 2 hour, I can make a 2 hour test. So I make 2 hours. So basically, what I usually do is, the test would be somewhat longer than what you had seen earlier. So it would be like 50% bigger, but then you have double the time.
No, we don't have double the time.
Pardon me?
We have 45 minutes more, right? So it's not actually double the time.
Oh yeah, that's good you pointed that out. So you have only 45 more minutes.
Yeah.
That means it is, so library is 1 hour 15 minutes.
Yeah.
So that's 75 minutes. Oh, that's good. So maybe I should try to make it like
30% more.
25% bigger. Okay, but it probably doesn't matter because it's sort of relative, and also I guess the decision on it's not necessarily absolute. So if I decide that a test was hard, then I can make appropriate adjustment. So yeah, so perhaps it would be like 25% bigger than what we had before. And project report was due.
It's due tonight.
It's due tonight?
Tonight.
Okay, so I look forward to reading your project reports then. So it's due tonight, and I think there's a late period. So I think there's a 24-hour late period. So if you don't mind losing a few points, you can submit it late. But if it is ready, then You probably don't want to lose a few points.
And we're also supposed to submit a hard copy and soft copy of it.
Soft.
No, just electronic. Yeah, just a PDF,
Yeah.
PDF or Word.
Yeah.
So submit it electronically, so yeah, hard copy is not needed. So, so has anyone already submitted it?
I submitted mine.
Oh, okay, that's good.
I'm about to submit like an hour probably just.
No, you have a hard copy already?
Yeah, it's just for the punctuation and stuff.
Oh, I see, okay. Yeah, yeah, I don't need a hard copy. I guess I will eventually need a hard copy, but I'll print it off from your submitted manuscript. So I will see you on Monday then.
So do you have any available hours tomorrow?
Tomorrow is Friday, and Friday, listen, I want a student on about 11:15, and then in the afternoon. Did we decide to have a meeting tomorrow afternoon?
No, sir, you haven't confirmed that, so.
Okay, so, but we were thinking about meeting at 2 o'clock.
No.
No?
Which research?
Okay, so. Yeah, I guess I would be around. So I am meeting a student at 1:15, and usually that's for planning for the next year. He's a TA, and since actually there is no, there are no more recitations, so our meeting probably would be brief. So I probably would be available. So if you are there, you can see if I'm free, like 11:45 or so. But I should also be around in the afternoon. So if you see me, you can stop by.
Thanks.